Bismillahirrahmanirrahim. Assalamu alaikum. I am Professor Hassan and you are watching my channel Professor Hassan Hamayu. Insha'Allah, today I will complete the topic of non-parametric tests. In the last lecture, we have discussed very important conceptual and tricky multiple choice questions, and I will just give you the recap. I will just revise all these concepts in a few minutes. First of all, I told you that non-parametric tests are also called distribution free test. There is not the condition of normality in non-parametric tests. They are used for the ordinal data, for the ranked data, and they are used when we have small samples, whenever we have n less than 20. And in non-parametric test, we test the location parameter. Then we discussed the first one, which is the easiest and the oldest test, and that is sign test. In sign test, we use the signs. And what is hypothesis? M is equal to M naught. We check the specific value of the median, and in the data, the value which is given to median, that takes 0 and it is discarded. For example, there were 9 values in the data. 2 are equal to the median value. Both will take 0, they will be discarded, and small n will be equal to 7. 9 minus 2 is 7. Then in sign test, X is the test statistic, which is the smaller number of signs, less frequent signs. If plus is 5 times, minus is 3 times, X will be equal to 3. Then I discussed it has the distribution, binomial distribution, and then we have discussed very important Wilcoxon signed rank test, in which we take the differences as well as magnitude, and it is used as an alternative to the paired differences for the t-test. Then I told you the test statistic of Wilcoxon signed rank, it is t, and it is minimum of t plus or t minus. And then we have discussed the Wilcoxon rank sum test, in which test statistic is R, which is the sum of the ranks of the smaller sample. There are 2 samples. For example, sample number 1 has 5 observations, sample number 2 has 8 observations. Then for the small sample, which consists of 5 values, the sum of the ranks will be R, the test statistic. Now next question, number 24. We have discussed 23 in the last, and I will complete inshallah today. When n1 and n2 are greater than 10, when n1 and n2 are greater than 10 in Wilcoxon rank sum test, then it is approximated normally with mu r is equal to n1 into n1 plus n2 plus 1 whole divided by 2, and sigma r is given, that is under the root n1 n2 into n1 plus n2 plus 1 over 12. Dear students, you will have to learn all these concepts. Next question is a very important test, which is Mann-Whitney-U test. It is the alternative. It is used for the 2 independent samples. It is the alternative to the t-test for the independent 2 samples. And for example, if I say you in hypothesis we make m1 is equal to m2 for the medians, then the test statistic is U, which is minimum of U1 and U2. Now I will tell you what is U1. U1 is equal to n1 n2 plus n1 into n1 plus 1 whole divided by 2 minus r1. And what is r1? R1 is the sum of the ranks of the first sample, and R2 is the sum of the ranks of the second sample. U2 is equal to n1 n2 plus n2, like this much, n2 plus 1 over 2 minus R2. Now after getting the value of U1 and U2, which will have minimum value, that will be the value of the test statistic U, a very important concept. Then if n1 and n2 are greater than 8 in Wilcoxon rank sum test, n1 and n2 greater than 10, it is approximately normal distribution. But in Mann-Whitney-U test, if n1 and n2 are greater than 8, we have the normal distribution, in which mu of u will be equal to n1 n2 over 2. Please learn this formula. And sigma u is equal to under root n1 n2 into n1 plus n2 plus 1 whole divided by 12. Then the next test is run test for randomness. Run test is used for checking the randomness. For example, I have a sequence H T T T H H T H T T H. For example, the question can be asked, run test is used for what? For randomness, and it is given. Now how you will have to check it. H, then there is a pattern change, tail is over there. One run, second run, third run, fourth run, fifth, sixth and 7. The 7 will be the answer. There are 7 runs in that one. Next question is, when n1 and n2 are greater than 10, the number of runs are approximately normal with mu r is equal to 1 plus 2 n1 n2 divided by n1 plus n2, and sigma r will be equal to under the root 2 n1 n2 2 n1 n2 minus n2 divided by n1 plus n2 whole square, n1 plus n2 minus 1. Then Kolmogorov-Smirnov test for goodness of fit. Kolmogorov-Smirnov test is used for the goodness of fit. In Kolmogorov-Smirnov test we use the cumulative distributions. Then the next question is question number 32. One sample Kolmogorov-Smirnov test was proposed in 1933 by A.L. Kolmogorov. Then two sample test was developed in 1939. Very important question, by N.T. Smirnov. The first one was A.L. Kolmogorov, second was N.T. Smirnov. Next question, it is based on cumulative distribution functions in the two sample. What is the hypothesis? H naught. That can be asked. F1 x1, it is for cumulative distribution, is equal to F2 x2. When n1, very important question, when n1 and n2 are greater than 40, then it approaches to chi-square distribution. It approaches to chi-square distribution with 2 degrees of freedom. Next question is Kruskal-Wallis one-way analysis of variance. Dear students, I will have to tell you one thing very important. If we test the hypothesis, for example, mu1 is equal to 40, we use z-test or t-test. If I talk about the parametric tests, whenever we have the testing of one sample, one population mean, we use t-test or z-test. If we have the hypothesis mu1 is equal to mu2, we use z-test or t-test. If the population standard deviation is given, we move towards z-test. If sigma is not given and n is less than 30, we move towards t-test. And whenever we have the testing of 3 or more than 3 means, mu1 is equal to mu2 is equal to mu3, we move towards analysis of variance, which is used for more than 2 means. And in non-parametric, if we are testing the 2 medians, there are 2 independent samples, then we have Mann-Whitney U-test as an alternative to the t-test for the 2 independent samples. And whenever 3 or more samples, then we use Kruskal-Wallis H-test as an alternative to the analysis of variance ANOVA for ANOVA one-way analysis of variance. And one more thing I want to tell you, for two-way analysis of variance, two-way ANOVA, the test which is used, it is Friedman's test. So what did you learn? I will have to revise it again. For the paired t-test, we use Wilcoxon signed rank test as an alternative, as a non-parametric test. And if I talk about Mann-Whitney U-test, it is an alternative to 2 sample independent sample t-test. Then Kruskal-Wallis is used as an alternative to one-way analysis of variance. Then the next one is Friedman's is used for the two-way analysis of variance. These all concepts are very important. Next question is, Kruskal-Wallis test is a generalization of Mann-Whitney U-test. As I told you, for 2 samples, we use Mann-Whitney U-test, and for more than 2 samples, we use Kruskal-Wallis H-test. and it was developed by Kruskal and H. Kruskal and W. Allen in 1952. Next question is, critical value of the Kruskal-Wallis test is calculated by chi-square distribution, a very important one. Next question, Kruskal-Wallis test is always one-tailed. It can never be two-tailed. Next is Friedman's test, which is the alternative to two-way analysis of variance. It is one-tailed. Next is t-test of a correlation coefficient is a parametric test for non-parametric Spearman's rank test. Next is non-parametric is used for small samples, variable is continuous or ordinal. Next, in non-parametric, we have interest in location parameter, as I told you earlier. Next question is, non-parametric tests are used to compare the distributions. Next, whenever we have non-normal population, ordinal data, small sample size less than 20, we use non-parametric. Next is relative efficiency in non-parametric is the ratio of the size of the samples. Relative efficiency is the ratio of the size of the samples. Next is non-parametric is based on ordered statistics. Next, we find confidence interval for the population median. Please keep in mind, we are talking about the median. We find out the C.I confidence interval for the median, not for the mean. Next question is very, very important. What is the rank of? The question is, what is the rank of the score 5 in? The question is 9, 3, 5, 10, 8, 5, 9, 7, 3, 4. Dear students, first of all, the smallest one. 3 is how many times? 2 times. It will take actually 1 rank, it will take 2. The average of 1 plus 2, 1 plus 2 over 2, it will be 1.5. So it will take 1.5. It will also take 1.5. Now 1 and 2 has been used. Now the third rank will be given to 4. It is 3. Now where is 5? 5 is how many times? 1 and 2. I will have to give 4th rank and 5th rank. 4 plus 5 over 2 is 4.5. 4.5 will be over here and here also. So what is the answer of the question? Rank of the score of 5 in that much is 4.5 is the correct answer. Next question is, if there are 0 differences in sign test, as I told you, they are discarded. When any value of the data is equal to median, that will be 0 and it will be discarded. Next, in sign test, samples are dependent. Next is, a signed rank test is an improvement of sign test. In sign test, we use the differences only. But in signed rank test, which is Wilcoxon signed rank test, we use the difference as well as magnitude, which is the alternative to the paired t differences, are very important. And in that test, we have test statistic t, which is a minimum of t1 and t2. t1 is the sum of the ranks of the plus 1, t2 sum of the ranks of the minus 1. Next is, the non-parametric for paired t-test is signed rank test. Next, in Wilcoxon signed rank test, t is equal to, as I told you, minimum of t plus t minus. Next, the best non-parametric for location parameter is Mann-Whitney U test is the best one. Next, the range of Kandal rank correlation coefficient is -1 to +1. Next, we use McNemer test for the qualitative. Next, Spearman's rank correlation test is used for strength of the relationship. Next is, for comparing 3 or more medians, we use Kruskal-Wallis H test. As I told you, in parametric, for the 2 means, we use Z or T. For 1 mean, we use Z or T. For, if I talk about non-parametric, for 2 means, for 2 medians, we use Mann-Whitney U test. For 3 or more medians, we use Kruskal-Wallis. But in parametric, we move towards analysis of variance. Next is, Kruskal-Wallis formula is based on ranks. It is based on ranks. Next question number 63. The test statistic H is Kruskal-Wallis is approximated by chi-square, not the normal. It is approximated by chi-square. Next, in Kruskal-Wallis, if we have k samples, then the degree of freedom will be k minus 1. Next, for two-way analysis of variance, the non-parametric test is Friedman. As I told you, for one-way analysis of variance, we have Kruskal-Wallis. For two-way analysis of variance, we have Friedman's test. Next, Kolmogorov's window test is used to check normality. Next, Glivenko-Kontelly theorem is associated with Kolmogorov-Smirnov test. Now 2 questions are left. Question number 71. Kolmogorov-Smirnov is two-tailed, left-tailed as well as right-tailed. Last question. If there are 10 symbols of two types, there are 10 symbols, they can be AB, they can be CD, they can be HT of two types, equal in numbers, then the maximum number of runs. A very important one. The last question is, if I have HT 3, 4, 5, 6, 7, 8, 9, 10, this is the demand. There are 10 symbols and they are 2 and all are equal in size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 runs. Dear students, I will wait for your comments, or the precious comments on today's video, because I have completed, alhamdulillah, today we have completed 4 important topics for the PPSC lecturer statistics paper. Assalamu alaikum.